This is the third lesson in Topic 10. In this lesson, we're going to be able to use the triangle congruency postulates and theorems that we've learned, the 5 shortcuts, to prove additional properties specifically for isosceles triangles. So if you remember, I think it was lesson 7.5, you explored several relationships that occurred within isosceles triangles, and you made these conjectures. So you were given triangle ABC with 2 congruent sides. Again, those are called legs of the isosceles triangle. So AB and BC were equal in length, and you had this median drawn, BD, segment BD. And so we learned these 4 things were true when we have this scenario. We learned the base angles are also congruent. The base angles are the angles that are opposite the congruent sides. So that would be angle BAC here and angle BCA here. Those are the base angles and they are congruent. We also learned that the median separated the original triangle ABC into 2 smaller triangles, ABD and CBD, and that those triangles are congruent to each other. One is simply a reflection of the other. We also learned that segment BD is an angle bisector. It is bisecting this angle ABC. And so that means that angle ABD and angle CBD are equal in measure. And that segment BD is a perpendicular bisector of segment AC. So we're creating right angles here and separating that third side AC into 2 congruent parts. AD and DC are congruent. So in other words, point D is a midpoint. So knowing this is a median also told me that it is an angle bisector, a perpendicular bisector, and of course it would be an altitude as well since these are right angles formed here. So if it's one of those segments, it's all 4 of them. So we have already proved the first 2 conjectures, and in this lesson we're going to prove the last 2 conjectures, that segment BD is bisecting angle ABC, and that segment BD is a perpendicular bisector of segment AC. So if you remember, what is a median? A median is one of those special segments of triangles that we learned, and this one starts at a vertex, like it starts at point B in this triangle, and goes to the midpoint of the opposite side. So D is a midpoint. So segment BD is a median starting at a vertex going to a midpoint. The second thing I want us to think about is what 2 angles have to be congruent if we're trying to prove conjecture 3, which is that this segment BD is an is bisecting angle ABC. Well, if it's bisecting angle ABC, ABC is being separated into 2 equal parts. What are those equal parts? Those are these 2 angles up here that both have a vertex of D. So one of them would be called angle ABD. The other one would be called angle CBD. Those are the 2 angles we need to be proving that are congruent. So see if you can complete this proof on your own. So pause the video and then you can restart it after you have tried it. So you have choices up here. Notice you have 2 triangle congruent statements, so be careful in choosing these. Make sure the corresponding parts are in the right order for the one that you choose. You can start the video up again when you are finished. Okay, so in this proof we are given AB is equal to BC, and we are given segment BD is the median of segment AC. And so those are the 2 things that were given, and those are the first 2 statements in our proof. So hopefully no one struggled with the first 2 reasons. They are both given. Now the third reason is given, and we have to come up with the statement. It says medians of isosceles triangles forms 2 congruent triangles. So if it forms 2 congruent triangles, what should we have here? We should have 2 congruent triangles. So we have 2 possibilities here of 2 congruent triangles. And like I said earlier, you got to make sure that you're showing the congruent parts. So hopefully you marked your figure. You have AB equaling BC here. And since we have this as a median, we know D is a midpoint. So we would also know side AD and DC are congruent to each other. So that'll help you know your corresponding parts here. So does angle D of the first triangle correspond to angle D of the second one? Well, this D is between the side with no tick marks and 2 tick marks. This D is also between 2 tick marks and no tick marks. So yes, those correspond. does A correspond to B? A is the angle between 2 tick marks and 1 tick mark. And then in the other triangle, B is between 1 tick mark and no tick marks. So no, that angle does not correspond to that angle. So this is not a correct order for a congruent statement. So the only other choice is triangle ABD is congruent to triangle CBD. A and C correspond because remember they're the base angles of the isosceles triangle. B and B correspond because remember this is an angle bisector. That's a reflection of one another. And then the D's are corresponding. Remember those are both right angles. So on number 3 you should have triangle ABD is congruent to triangle CBD. So number 4, remember after we have congruent triangles, we've talked about what the next step is almost always going to be in a proof. Once you prove triangles are congruent, what do you usually use after that? Hopefully you know that's CPCTC. So once we have congruent triangles, we know 6 things are true. All 3 pairs of corresponding sides are congruent, and all 3 pairs of corresponding angles are congruent. So now I know angle ABD, which is this angle up here, is congruent to angle CBD, which is this angle up here. And that is by, again, CPCTC. The corresponding parts of congruent triangles are congruent.
At this time, I need all the English teachers.
So if I know these 2 parts are congruent, we have proven what we were supposed to be proving. That's what an angle bisector does. It creates 2 angles that are equal in measure. So now we know what we were trying to prove has to be our last statement, and that is that segment BD is bisecting angle ABC. And the reason for that is the definition of what an angle bisector is. It is a segment that divides an angle into 2 equal parts. We have the 2 equal parts, so we have an angle bisector. All right, so now we're going to look at that 4th conjecture, and that is proving that segment BD is in fact the perpendicular bisector of segment AC. So we are given a couple of things in this one as well. We are given that AB equals BC. That's what makes this an isosceles triangle. So make sure you put tick marks on AB and BC. You're always marking your figure with the given information. We are also given that segment BD is the median of segment AC. Now you might think, okay, I'm going to automatically mark AD is congruent to DC, but that needs to be stated in your proof somewhere. So it doesn't specifically say segment AD is congruent to DC, even though it's implied with the median. That has to be a step in my proof. So what we're trying to prove again is that segment BD is the perpendicular bisector of segment AC. So we've got to prove 2 things are true. That we have a perpendicular relationship here, which creates 90-degree angles, and that these parts are congruent, AD and DC. So here is a hint of what you need to do. You need to first prove that these 2 smaller triangles are congruent, and then think about the 2 things that we just talked about that you have to prove in order to know it's a perpendicular bisector. You have to have a perpendicular relationship, which again forms 90-degree angles, and these parts have to be congruent to each other, AD and DC. Now there are a lot of different ways to do this proof. The proof that I'm going to show you has 12 steps in it. They are all steps that we should be familiar with. Nothing is crazy or brand new in here. But you guys have got to practice doing proofs on your own. So the easiest thing to do is just keep the video going and see my answers. But that's not going to help you get any better at proofs. So I highly recommend that you pause the video and try this on your own. You can always go back and make additions and corrections after you watch the video. But if you don't practice these on your own, you're never going to get better, and you're never going to do well on a test when you have to write a proof on your own. So practice makes permanent. You've got to practice before that becomes familiar with you. So pause the video, and then you can restart it and look at the answers. Okay, so in my proof, of course, I would start with the given information, and that is AB is equal to BC, and segment BD is the median of segment AC. You could put this in 2 different steps. That would be fine as well. but you can put them all in one step as well. So the next thing I did is I used the fact that we had a median to say that means that D is a midpoint. And that's by the definition of what a median is. Remember, a median is going from the vertex to a midpoint. So if I know if I have a median, then I know I have a midpoint. So my statement is that D is the midpoint of segment AC, and the reason is that's the definition of what a median is. Now I'm going to use the definition of what a midpoint is. So if D is the midpoint, what do I know as a result of that? I know that A to D and D to C are the same length. So that's my third statement. AD equals DC, and I'm going to mark that on my figure. Remember, I'm going to use 2 tick marks now because 1 tick mark has already been used with the given information. And that's by definition of what a midpoint is. All right, so that proves, remember, one of the things we needed to do. We needed to prove that those two parts were equal. Now we need to prove that perpendicular relationship. So I told you, remember your hint was to prove that the triangles are congruent first. Well, I have 2 parts congruent of each one of them now. I need a third part. The easiest one is the side that they share. So we know segment BD is congruent to itself or equal in measure. So if you don't use the segment bar, remember to use an equal sign. If you use the segment bar, you would use a congruent symbol here. So either BD equals BD or segment BD is congruent to segment BD. And that is the reflexive property. So now do we have enough information to say the 2 triangles are congruent? Yes, we have the 3 pieces of information, and what shortcut is that? So we know the 2 triangles are congruent by SSS. You did not have to name your triangles the same way I did, just make sure your corresponding parts are in the right order. So wherever you have A on your first naming, you should have C on your second one. The B's should be in the same place, and the D's should be in the same place. Now remember, that doesn't mean that's how that always is. Just because 2 triangles have the same letter as a vertex doesn't mean it will always be in the same place in your congruent statement. It's just that in this case, the B's were corresponding parts, and so were the D's. Now, what almost always follows proving triangles are congruent? Remember, almost always we're going to use CPCTC next. We can prove all 6 corresponding parts are congruent using CPCTC. We obviously wouldn't need to prove any of the side parts, corresponding sides are congruent, because we already have those in our proof. So it's an angle that we're looking at. And since we're trying to prove a perpendicular relationship, it's these 2 angles right here that BD is forming with AC that we're wanting to say are equal. So ADB is this angle, and CDB is this angle. So I'm going to add some arcs here and here. These are my congruent angles by CPCTC. Now notice those 2 angles make up a line together. So these 2 angles, ADB and CDB, are supplementary by the linear pair theorem. Since they make a straight angle together and they're adjacent, that makes them a linear pair, and the linear pair theorem says that means they're supplementary. Now, what does it mean for them to be supplementary? What does the definition of supplementary say? It says that that's 2 angles whose sum is 180 degrees. So the next thing I want to say is the measure of ADB and the measure of angle CDB have to add to be 180 degrees. And that's by definition of what supplementary means. So now, since we already know those 2 angles are equal, I'm going to use this substitution to replace the angle of CDB with the measure of angle ADB, because they're equal. So I did substitution since they were equal, replacing one with the other. Now I can do some simplifying there and add those because they're like terms. So I just did addition is all I did. So that's 2 measures of angle ADB. And I'm going to get rid of that 2 by dividing. So I'm going to divide that away, and that shows that the measure of angle ADB is 90 degrees. So if this segment makes a 90-degree angle with that segment, what can we say that those segments are? We can say that they're perpendicular. So now that we know they're perpendicular and we have those parts are congruent, AD equals DC, we have proven what we were trying to prove, that segment BD is in fact the perpendicular bisector of segment AC by definition of a perpendicular bisector.